Today, we will talk about the VFR Navigation Log, what information is included in it, and how to fill it out. First of all, we have to say that this format may have different names, such as Flight Log, Navigation Plan, or Flight Data Card. However, they all refer to a format that contains all the relevant information for the execution and monitoring of navigation in a VFR flight. There are several templates for this navigation logs in the market, but they all contain almost the same information. Normally on a VFR flight, there are several legs between relevant checkpoints on the route. So for each of these legs, the following information is required. First of all, there is the compass heading, which is the heading to be flown in that leg. And as we have already seen in previous videos, in order to determine this compass heading, we need to know the true course, wind direction and speed, true airspeed, wind correction angle, magnetic variation, and compass deviation. In addition to this, we require to know the distance of that leg, and the ground speed, which is determined by means of the true airspeed and the wind direction and speed. Then, with this information, the estimated elapsed time for the leg is calculated, as well as the fuel consumption. Now, after doing this with each individual leg, for the entire route in general, the following information is also required: total distance, total time, and total fuel consumption. To obtain these values, we simply add up the individual values for each leg, thus obtaining the totals. Now, depending on the format, some navigation log templates may include other fields to be filled out, such as communication frequencies, Navaids, meteorology, aircraft performance, and airport information. Now, in order to get familiar with all this, let's look at the Jeppesen and ASA Navigation Log templates, which are widely used around the world. First, let's look at the Jeppesen format. On the left side we have some fields to include the names of the different checkpoints on the route, and as we know, on VFR flights, these checkpoints may be towns, rivers, lakes, roads, or any other landmark visible from the cockpit. Now, if any of these checkpoints is associated or is very close to a Navaid, we can use it as reference as well, so the identifier and frequency information is included in the fields next to it. Then we have the course section, where we will include the true course for each leg. Then, in the altitude section, we will include the altitude at which we will fly each leg. Then, in the wind section, we will include the forecasted wind direction and speed, as well as the outside air temperature for each leg at the planned altitude. Then we find the calibrated airspeed field at the top, where we will include the planned cruising indicated airspeed, and in the fields below, we will include the calculated true airspeed for each leg. Then, we have the courses and headings section, where we will take the initial true course and apply the corrections for wind, magnetic variation, and compass deviation, thus obtaining the compass heading for each leg as a result. After this, we find the distance section, where we will include the total distance of the route at the top and at the bottom fields, and for each individual leg, we will include the distance between the checkpoints and the remaining distance to the destination airport. Then, we find the ground speed section, where we will include the estimated and the actual ground speed for each leg. Then, we have the times section, where we will include the takeoff time at the top, the estimated and actual times for each leg, and the total time at the bottom. Then, there is the fuel section, where we will include the estimated fuel consumption per hour at the top, the estimated fuel consumption, and remaining fuel on board for each individual leg, and the total trip fuel at the bottom. Finally, on the right we find other fields where we can include information related to communication frequencies, weather conditions, and log times. Now, the ASA format contains almost the same information, but in a different layout. At the top we find the log times and weather conditions. Then from left to right we find the true course and altitude sections, then the wind and temperature sections, the true airspeed and wind correction, the courses and headings section, the checkpoints, the compass heading, the distance, the ground speed, the time section, the fuel section, the Navaids, and the transponder. Finally, at the bottom we find some fields to include additional notes and information related to the airports. Now that we know how is the information arranged in this navigation logs, let's look at how to fill them out. For this, we will use both Jeppesen and ASA templates to fill out the information corresponding to a VFR flight of about 100 miles in a Cessna 172. So with this being said, let's start with the ASA template. Here, the first leg will be from Sierra Kilo Victor Victor, which is our departure airport, and Cumeral, which is a little town that will be used as a checkpoint on the route. So from left to right, we include the true course of this leg, which in this case is 053, the altitude will be 3,500 feet, the predicted wind direction and speed at that level is 080 degrees at 20 knots, and the expected outside air temperature is 23 degrees Celsius. In the same way, let's use this information to fill out the Jeppesen template. Here, from left to right we include the checkpoints, and in this case, the departure airport has a VOR associated to it, so then we include the identifier and its corresponding frequency. Then, we include the true course of 053, the altitude of 3,500 feet, and the wind direction, speed, and temperature is included according to the format shown above. Let's now continue with the following sections. In the ASA format, there is not a field to include the planned indicated airspeed, so we just include the calculated true airspeed for that leg, which in this case is 110 knots. Then, we put the wind correction angle, which is +5 degrees in this leg. Then we find the courses and headings section, where we will apply all the corrections in order to obtain the compass heading. So as we can see in the template, the first one to be applied is the wind correction to obtain the true heading. So using as reference the previous true course of 053, we add up the wind correction of +5 degrees to obtain a true heading of 058. Then, the following correction to be applied is the magnetic variation to obtain the magnetic heading. So in this case, below the true heading of 058 we include the magnetic variation for this leg, which in this case is 7 degrees west. Then, we take the previous true heading and add the variation of 7 degrees, thus obtaining a magnetic heading of 065. Then, the final correction to be applied is the compass deviation, which in this example is -2 degrees. So then, we take the previous magnetic heading of 065 and subtract the deviation of 2 degrees, this obtaining a compass heading of 063. Let's now put all this information in the Jeppesen template. In this case, we do have a field to include the planned indicated or calibrated airspeed, which in this case is 101 knots. Then, we include the calculated true airspeed for this leg, which is 110 knots, and then we find the courses and headings section. Here we include again the previous true course of 053, and we proceed exactly in the same way as with the ASA template. We put the wind correction angle of +5 degrees to obtain the true heading of 058, then we include the magnetic variation of 7 degrees west to obtain a magnetic heading of 065, and finally we include the compass deviation of -2 degrees to obtain the compass heading of 063. Now, having completed these sections, we find the distance section. In this case, we have to include the leg distance in the upper field, and the distance remaining to the destination airport in the lower field. So assuming that the total distance of the route is 102 nautical miles, we include the leg distance of 11 miles, and the remaining distance of 91 miles. Then we find the ground speed section, where we have to include the estimated ground speed in the upper field, which in this case is 92 knots. Then, we find the time section, where we have several acronyms. In this case, during the flight planning, we just have to fill the ETE field, where we have to include the estimated time for the leg, which in this case is 7 minutes. The rest of the fields will be filled during flight. Then, after this we find the fuel section, where we have to include the estimated fuel consumption for this leg in the upper field, and the fuel remaining in the tanks upon reaching the checkpoint. In this case, let's assume that the aircraft takes off with 50 gallons in the tanks. This way, if the fuel used during the leg is 3 gallons, the fuel remaining would be 47 gallons. Then, we find the Navaid section, where we can include any relevant Navaid and a reference radial from it. In this case, as we previously mentioned, the departure airport has a VOR associated to it, so we include here its identifier and frequency. Now, this VOR can be used as reference for navigation, so we include the radial that passes through the first checkpoint, which in this case is the radial 341 from the VOR. Now, up to this point we have already completed all the fields required during flight planning. Let's now see how to fill the remaining data during flight. In this case, since we are departing from a controlled airport, the first thing that we will include here is the squawk or transponder code, which will be assigned by the control tower before departure, and in this case it is 1024. Now, let's say that the aircraft takes off at 14 o'clock, so according to the estimated time en route of 7 minutes for the first leg, the estimated time of arrival to the first checkpoint would be 1407. However, let's say that the aircraft reaches the checkpoint at 1406. This means that the actual time en route for this leg was 6 minutes, and therefore the actual ground speed was about 110 knots. Now, using the same method, we can fill out the Jeppesen template. However, the difference is that here we have additional fields for specifying the total distance of the route, the takeoff time, and the average fuel consumption per hour, which must be filled accordingly. Now, in the miscellaneous part of the templates we will find additional fields that may include information related to weather conditions, log times, airport information, communication frequencies, and additional notes. For example, in the ASA template, in the upper part we find some fields to be filled during flight planning, such as the aircraft's tail number and the average fuel consumption per hour. And there are also some fields to be filled during flight, such as weather information, the block off, take off, and block on times. Then, in the lower part of the navigation log we find some other fields related to airport information, which should be filled out during flight planning. Now, in the Jeppesen template we have very similar information, it's just that it is arranged in a different way. Now, in addition to filling out this navigation log, a very useful way to keep a high situational awareness is to complement this information with a graphic representation of the route, including the most relevant data, such as compass heading, distance, time, and fuel for each leg, as we can see in this example. Having seen all this, you might be wondering, what is the correct order for filling a navigation log? Well, before doing so, we have to make sure we have all the necessary tools and data, which are a VFR navigation chart of the area, a plotter, a flight computer, the aircraft performance tables and graphs, the winds and temperatures aloft, and the compass deviation card of the aircraft. Once all this is available, the first step is to determine the route and the checkpoints using the navigation chart. Then, using the plotter, determine the true course and distance for each leg. Then determine the cruising altitude and look at the forecasted wind and temperature at that level for each leg. Then, using the performance tables of the aircraft, determine the expected indicated or calibrated airspeed, and with the previous information determine the true airspeed, ground speed, and wind correction angle for each leg. Then, determine the true heading, the magnetic heading, and the compass heading for each leg. Then, using a calculator or the flight computer, determine the estimated time en route for each leg. Then, using the performance tables of the aircraft, determine the average fuel consumption per hour and calculate the fuel required for each leg. Then totalize distance, time and fuel for the entire route. And finally, fill out any other relevant information. Now, so far we have seen how to fill out the navigation log assuming a certain constant altitude for each leg. However, in reality, we have to climb from the departure airport elevation to the cruising altitude, which implies that our fuel consumption during this phase will be higher and probably our ground speed will be lower. For this reason, some pilots include what is called the top of climb in the navigation log. The top of climb is basically the point at which the climb phase ends and the cruise phase begins, or in other words, it is the point at which the cruising altitude is reached. The position of the top of climb can be calculated by means of the aircraft performance tables and graphs, or by using approximate calculations, and in many cases, it is included as a checkpoint in VFR navigation logs. Now, in the same way, the aircraft has to descend from the cruising altitude to the destination airport elevation, which implies that during this phase the fuel consumption will be lower and the ground speed will probably be higher. For this reason, the top of descent is sometimes included in the navigation log. This is basically the point at which the cruise phase ends and the descent begins. The position of this top of descent can be determined using the performance tables of the aircraft, or by means of approximate calculations, and as with the top of climb, in many cases it is included as a checkpoint in VFR navigation logs. Here we can see an example of a navigation log that includes the top of climb and top of descent as checkpoints, and how the speeds and fuel consumption change during these phases. In this other example we can see the same information, but in the Jeppesen template. And here, we can see the same flight, but in a graphic and simplified representation, which can be adapted to include other information, such as terrain features or Navaids. Finally, we have to say that some templates include a backside, which may contain additional fields related to meteorology, the ATC flight plan, NOTAMs, PIREPs, or weight and balance considerations. This particular example is the backside of the Jeppesen template, which is adapted to the standards and requirements of the FAA, but it might be useless when flying in other countries under different regulations. I hope the information presented in this video was useful. If so, don't forget to share, like, subscribe, and leave a comment down below. Thanks for watching.